It's no surprise that as the world population continues to grow, the limits of essential global resources such as potable water, fertile land, forests, and fisheries are becoming more obvious. You don't have to be a genius to work out that, on the whole, more people use more resources and create more waste. So, how many humans do you think there will be here on Earth when we reach what is known as peak human population? I can tell you that right now there's about 7.9 billion humans, and that this number has yet to stop rising. So, what is your guess? 9 billion? 10 billion? 100 billion? Well, if your guess was anywhere between 9.7 and 10.9 billion, you'd technically be correct, because it turns out estimates for the amount of humans Earth will contain at its peak vary quite a bit depending on who you ask. The United Nations is confident that 10.9 billion people will eventually roam Earth's surface, and other studies done by the Lancet, for example, indicate that the magic number is closer to 9.7 billion. So just to make everything easier, let's say the human population will peak at 10 billion. Great. Now comes the more difficult question. When will this happen? Again, guesses by the smartest people vary by a lot. 4 decades in fact. So anywhere between 2060 and 2100 is the best guesses we have. So let's just say 2080 is when we'll reach peak human population. Now comes the hardest question of them all. What happens when we reach peak human population? Do we have enough space for all these people? Is there enough food and water? What will the consequences be? Well, that's what I wanted to figure out, and what I found is quite horrifying. And it turns out the biggest problem of all, in regards to a population size, is something I could have never imagined. But let's start with whether or not we have enough space for everyone. The total land surface area of Earth is about 57.3 million square miles, of which about 33% is desert and about 24% is mountainous, which are not ideal places for human survival, so let's subtract this uninhabitable land from the total, which amounts to 57% or 32.6 million square miles of the total. This leaves 24.6 million square miles or 15.77 billion acres of habitable land. Divide this figure by the peak human population of 10 billion, and you get 1.5 acres or about 0.6 hectares per person. However, in these calculations, we have not allowed for any amenities such as highways, schools, hospitals, agricultural fields, and so on. So maybe 1.5 acres is a bit generous, but even so, there should be enough space for us all, which means space is not the problem. So what about food? Well, according to the Food and Agriculture Organization of the United Nations, the world already produces more than 1.5 times the amount of food we need, and that means we already have enough food to feed 10 billion people. Unfortunately, neither the study nor the conventional wisdom addresses the real cause of hunger. Hunger is caused by poverty and inequality, not scarcity. So while we do have plenty of food for everyone currently, we would be in great trouble if we all started living like an average American, as an average middle-class American consumes 3.3 times the subsistence level of food and almost 250 times the subsistence level of clean water. So if everyone on Earth lived like a middle-class American, the planet would have a carrying capacity of around 2 billion people. But on the topic of water, do we have enough of it? Well, fresh water makes up a very small fraction of all water on the planet. While nearly 70% of the world is covered by water, only 2.5% of it is fresh. The rest is saline and ocean-based. Even then, just 1% of our fresh water is easily accessible, with much of it trapped in glaciers and snowfields. In essence, only 0.007% of the planet's water is available to fuel and feed the future 10 billion people. While the amount of fresh water on the planet has remained fairly constant over time, continually recycled through the atmosphere and back into our cups, the population has increased a lot. This means that every year, competition for a clean, copious supply of water for drinking, cooking, bathing, and sustaining life intensifies. Though, despite this, there still should be enough for everyone. So, what about resources? First and foremost, we must discover new resources, preferably those with high concentration of the critical commodities that we need. Think metals and hydrocarbons. Over the past few decades, extraction of many natural resources has become more difficult. Many current mines have lower concentrations or grades of metals and minerals than in the past. Hydrocarbons are extracted from more complex, lower permeability host rocks, and deeper aquifers must be tapped for water. As a result, we expend more energy, disturb more land, and spend more per unit of production than in the past. The discovery of new high-quality, high-value deposits can reverse this trend, allowing increased efficiency of extraction per unit of commodity. Making such discoveries is challenging, but recent history demonstrates that there is considerable potential for more discoveries, especially at modest steps. In spite of rapid increases in the use of all natural resources, the extractive industries have kept up with demand. It seems that as long as there's an economic incentive to keep finding new deposits, we will keep finding them. Which means, so far, we've ruled out land, water, food, and resources as potential causes for concern. And that leaves pretty much nothing to be worried about when it comes to peak human population. But despite this, it seems that the scientific consensus of how many people Earth can sustain, also known as the carrying capacity, vary immensely. Debate about the actual human carrying capacity of Earth dates back hundreds of years, and today, the range of estimates is enormous. I mean, take a look at this. These are 65 independent studies on this matter, and here's what they've all concluded. Fluctuating from 500 million people to more than 1 trillion. Scientists disagree not only on the final number, but more importantly about the best and most accurate way of determining that number, hence the huge variability. So Earth will probably be able to sustain 10 billion people, but we're not quite sure. What we are sure of though is that hitting peak population is not our biggest concern. It's instead what happens immediately after we hit it. And this is where the video takes a turn. You see, once we hit peak human population, it won't stay at 10 billion. Instead, it will decline, which you might believe is a good thing, but let me tell you, it's possibly the biggest challenge humankind has to overcome. While overpopulation puts a strain on natural resources, increases conflicts and wars, and causes water shortages and malnutrition, population shrinkage presents possibly way worse issues. And this population decline thing is not far into the future either. Oh no, it's already happening. In rich countries, for example, fertility rates have hovered below the replacement level of 2.1 for decades. And if you're wondering what the 2.1 means, it's the amount of children women need to have on average to sustain the population. So yeah, that's pretty worrying, and it's not just rich countries either, as middle-income countries across the world are also below the threshold, from Iran to Thailand and Brazil. More extreme examples include South Korea, where the fertility rate dipped to just 0.98 last year, and in the US it hit an all-time low of 1.73 births per woman. Now, according to the latest World Population Prospects from the UN, 27 countries have fewer people now than they did in 2010, and it expects 55 nations, including China, to experience declines between now and 2050. So what are the consequences of this? Well, some of the economic consequences are pretty obvious. Fewer people make and consume less stuff. So a declining population means slower economic growth, or most likely an economic recession. The main concern with an economic recession is weak demand for investment, since companies expect a declining customer base, exactly the opposite of what you should expect as a company and investor, which will lead to deficient demand and thus high unemployment. In a new paper, provocatively titled The End of Economic Growth, Stanford University economics professor Charles Jones models what might happen in a world of declining population. Rather than per capita growth just chugging along, even as overall output declines, Mr. Jones argues that living standards would stagnate as the population gradually vanishes. He assumes that economic growth ultimately comes from new ideas, and the discovery of new ideas depends on the number of people researching them. So, if population began to decline at the global level, it would mean ever fewer people devoted to research and thus ever slower progress, at a time when new technologies already seem to become harder to find. But there is an even more alarming possibility, a vicious cycle in which low fertility in one generation causes low fertility in the next, leading to a never-ending downward spiral in population. This is the scenario that demographer Wolfgang Lotz and colleagues call the low fertility trap hypothesis. They propose a set of mechanisms whereby low fertility can pass itself from generation to generation. In particular, they suggest that willingness to marry and have children depends partly on whether a couple can meet with their material aspirations. But low fertility also goes hand in hand with aging populations and a rising tax burden to pay for pensions and healthcare. There's reason to suspect these mechanisms are already at work in suppressing fertility. In Japan, for example, almost all recent income growth for people of working age has been soaked up by tax rises and social insurance premiums to pay for the aging population. What is quite scary about Japan in particular is that Japan's population is projected to have already peaked in 2017 at 128 million people, and that this number will decline to just 53 million by 2100. So hopefully we will not end up in Japan's situation, but it seems population growth is not something we should be concerned about, but instead the population declining. That's it for this video. If you liked it, please subscribe down below and let me know what you think. Thank you for watching, and I'll see you in the next one.